Section 6.6 is called life expectancy of electrical apparatus. And Wildy tells us at the beginning of this section 6.6 is outside of catastrophic mechanical and electrical failures, the temperature of the insulation of electrical apparatus has the largest bearing on the life expectancy of that electrical equipment. So when we're talking about temperature, of course, what we're talking about, the higher the temperature that the electrical apparatus is subjected to, the shorter the life of that apparatus. And tests are made on many types of insulating materials have shown that the service life of an electrical machine or electrical apparatus diminishes approximately by half every time the temperature increases 10 degrees C. This means that if a motor has a normal life expectancy of 8 years at a temperature of 105 degrees, it will have a service life of only 4 years at a temperature of 115 degrees C, and then of 2 years at 125 degrees C, and only 1 year at a temperature of 135 degrees C. So as we can tell, it's a big, it's a big deal, in terms of the effect that it has on electrical machines. And sometimes, I would say in a lot of applications, it's a forgotten factor. Some of the other factors outside of temperature that might occur, and contribute to the deterioration of insulation are listed here in Figure 6. Just a general category of time. Of course, we just high temperature, and I think here we're talking probably more about operating in a high ambient. Humidity, chemicals, things like fungus, dust, rodents, animals can have an effect on the life of insulation. The actual ozone, which occurs when there's arcing, and it's the combining of oxygen, the creation of ozone, noxious gases such as sulfur dioxide here, vibration. This is thinking more in terms of the environment that maybe this is operating in. And some of these things can cause the insulation to crystallize. We might think of it more as a hardening. And as all this occurs, the insulation becomes less able to do what it's intended to do. And once this thing crystallizes, hardens, you can get a crack or a break in it, and all sorts of things occur when this happens. He goes on to say that organic insulators have a life expectancy of 8 to 10 years, provided their temperature does not exceed 100 degrees. On the other hand, there are synthetic polymers that are used for insulation that can withstand temperatures as high as 200 degrees C for the same time. So, there's a wide range of variation here within what electrical machines can manage. And he goes on to say low temperatures can be just as harmful as high temperatures, the freezing and cracking that can occur. So, both are considerations. But I do want you to think about, that one thing, and that was in the first paragraph where he says that if a motor has a normal life expectancy of, say, 8 years, and that life expectancy is given at a temperature of 105 degrees C, then if you ran that same machine at 115 degrees C, that same machine would have a service life of only 4 years. And then again, if you ran this at 125 degrees C, 2 years, and then, even continuing on to 135 degrees C, you're down to 1 year for a machine that should have been able to operate 8 years at a temperature of 105.